This short presentation introduces some topics on plotting in Octave. We're going to work with 2D plots, and here's an example script to start off with plotting a single point. So we're going to create variables x and y, assign them values, and then call the plot function where we pass it x and y. And then we have this extra argument r and then the asterisk. And after we call the plotting function, we're going to modify the plot by defining the axis range, giving it a string for the x label and one for the y label, and then putting a title on the plot. And here's what we would get. So we plotted our single point and we used a red asterisk for our marker type. And then you can see the ranges for the axes are the arguments passed into axis. Well, really it's one argument, vector. And the first two elements are the x range and the second two elements are the y range. Whenever we want to plot more than one point, we create vectors. So a vector for the x coordinates of the point and a vector for the y coordinates. For example, we're going to plot these 6 points, and here we have this column is all the x coordinates and this column is all the y coordinates. So we will create a variable that's a matrix or a vector of the elements of the y coordinates, and then a vector that's the y coordinates. So this is a vector of the x coordinates and this is a vector of the y coordinates. And we pass those to the plot function and it will plot all those points. So by default, plot is going to produce a line chart where the points are connected by a solid line. But we can change the options on the marker style or the line style. So we could change the color that the things show up with. We could change the markers if we want them to show up as discrete points. Then we can have all these different markers like circle, diamond, hexagram, pentagram, so a 6-pointed star. And then if we wanted to use lines, we can have different styles of lines. So dash line, a dash dot, a dotted, or a solid line. So those would all be extra arguments that we would pass into the plot function. In addition to these, we have functions that are useful whenever we're using plotting. The CLF function clears the figure window, so this will leave up the window, but it'll clear the contents of the window. The figure function creates a new empty figure window, and we can have multiple figures by calling figure and then passing it a number. So figure, if we call figure and pass it 1, then that window will be called figure 1. If we call figure and pass it a 7, then that would be figure 7. And then we can refer to all these different figures later. The function hold on freezes the current graph in the figure window so that we can then add another plot on top of it. We can also use hold off if we want. And then if the hold is off, then whenever we call the plot function, it's going to overwrite the previous curve, whereas hold on will keep multiple curves in the figure window. And then finally, legend allows us to create a legend to identify each of the curves in the figure. Well, now finally, grid on displays grid lines if we want those in our plots. So for this example, we'll see creating 2 plots, superimposing curves, multiple curves on one figure window, and then modifying the marker size and line width. To start off, we will create our x vector and using the linspace function. So it's 100 points going from negative pi to pi. And then c is just the cosine of x, s is the sine of x, and t we assign the value of tangent of x. Now here are our plotting commands. We create a new figure window. It's named figure 1. And we call the plot function. So in figure 1, we're going to plot the tangent versus our data points. And we're going to plot that with a dotted line, a magenta dotted line. So that's what this argument means. And then the line width property, we're going to assign a value 4. So it's going to be 4 times the normal line width, because otherwise it shows up as being too thin. Now figure 2, we're going to make a new figure. So we'll keep figure 1 and we'll also add figure 2, and we plot the sine with black dots and marker size 7, so each marker is going to be 7 times taller than it would have been normally. And then call hold on so that we can superimpose another curve on this figure, and that's going to be the cosine green solid line, and we have a line width of 7 times normal. And then we add a legend, so sine and cosine, and the order that we pass these arguments to legend corresponds to the number of the curves. So sine corresponds to the black and cosine corresponds to the green.